Hello everyone, welcome to Fundamental Mathematics. This is going to be unit 6.2. 6.2 is looking at conversion, specifically in the metric system. Now in 6.1 we just got done talking about the imperial or the US system. The metric system is nice in that it is very simple, relatively, to convert. Everything in the metric system is a base 10. So we are going to be either multiplying or dividing by factors of 10. Now, that being said, we need to be familiar with prefixes, those little, parts of words that are in front that indicate a value. So when we look at meters or grams or liters, we're familiar with what each of those prefixes represent. So when you look at a conversion rate for the metric system, typically what you're going to see is a little table that looks something like this. And it could be the same table for meters. It could be the same table for liters. It could be the same table for grams. But you start out and you're going to see lines going all the way through of different values. 1, 2, 3. Try to do it here. 1, 2, 3. And that's okay. And so you start in the middle, 1, 2, 3, 4, 5, 6, 7. So right here in the middle, this is where your grams, your liters, etc. are going to be. So this represents a 10 to the 0, just a regular unit of measurement, 1 gram, 1 liter, 1 meter. Now, when you get bigger, there are prefixes that represent each of these values. 10 to the 1, 10 to the 2, 10 to the 3, etc. Now, depending on what you are measuring, sometimes you'll even go further than this. And after, let's say, 10 to the third power, typically they're going to skip a few, and then the next one here would be 10 to the 9, 10 to the 12, going by multiples of 1,000. However, for our sake, we want to be familiar with a certain level of measurement. Now, again, some diagrams will go the opposite way, etc. But if I'm looking at, let's say, 10 to the third power, the prefix for this is going to be K, and the word prefix for this is going to be kilo. Kilo represents 1,000. 10 to the third power, 10, 100, 1,000 represents 1,000. So if I have a measurement in that place, that represents 1,000. So for instance, a kilogram is 1,000 grams. A kiloliter is 1,000 liters. A kilometer is 1,000 meters. There are names for times 10 or times 100. There are names for times 10,000, times 100,000, times a million. However, for our class, we're not going to usually use a lot of these. For instance, 10 to the 6th power, which is a million, represents mega. 10 to the 9th power, represented by G, represents giga. We hear those terms a lot with computers, megabytes, gigabytes, but for our assignment here, we're not going to need those conversion rates. We're primarily going to be going from grams to kilograms, kilograms to grams, and vice versa. But you should be aware of those. If you're taking a chemistry class or an integrated math 2 class, or sorry, integrated science 2 class or above, you'll use that a lot. And in integrated math 2, integrated math 3, you'll review scientific notation and where these unit conversions come in. But for now, this is the big one on the higher end you want to be familiar with is kilo represents 1,000. You do need to be familiar with that. Now, going the other way, same thing. There is a name for 10 to the negative 1st power, 10 to the negative 2nd power, 10 to the negative 3rd power. But for us, for this class, the two that we are primarily concerned with are 1/100th. Remember, with negative exponents, this is representing a smaller value. So 10 to the negative 2 is 1 over 10 squared, or 1 with 1/100th. And this is represented by centa. So a centigram, a centiliter, a centimeter, etc. And then 10 to the negative third represents 1/1000th. And that is represented by milli or m. So a millimeter, a milligram, a millimeter, etc. This is represented by lowercase m. This is represented by lowercase c. And again, there are names for 1/10,000th, 1/100,000th, 1/1,000,000th. But these, for now, are the ones that you need to focus on. Milli, centa, your base unit, and then kilo, which represents 1,000. So based on those prefixes, you should be able to convert from one to another. All of these are going to involve either multiplying by a factor of 10, 100, 1,000, etc., or dividing by a factor. For instance, let's say I wanted to convert 500 grams, and I want to convert that to kilograms. Okay. There's a couple ways you can approach this. Now, we just got done with 6.1 looking at unit conversions, right? And so we used sort of our unit factor, our scale factor to say, okay, well, 1 kilogram is represented by 1,000 grams. So essentially what I'm doing is 500 divided by 1,000, which would give me 1/2 or 0.5 kilograms. Now, because we're using a base 10 system and decimals are base 10, you want to leave your answer as a decimal. I wouldn't mark it wrong if you put it as a fraction, but the expectation is that you're using the decimal system. And so if you were doing this on a multiple choice, you're not going to have any answers that are fractions. They're all going to be decimals. Now, okay, well, why is that relevant? Because if I asked you to convert 500 grams to kilograms, remember that anytime you divide by a factor of 10, you're essentially just moving the decimal over because it's a base 10 system. So to divide 500 by 1,000, I would divide it by 10, divide it by 100, divide it by 1,000, and there's my answer. The expectation is that you're able to do this without a calculator. You're moving the decimal X amount of places to the left if you're dividing, or X amount of places to the right if you're multiplying. So it's a way of doing this without actually having to pull out a calculator. Let's do another example. Let's say I have 40 meters and I want to convert that to centimeters. Same thing, you can use your unit rate if you'd like, or I would look at this and say, okay, there are 100 centimeters for every meter. So I would take 40, move the decimal over twice, and that gives me 4,000 centimeters. You would get the same thing by multiplying by the unit rate, 100 centimeters per 1 meter. But using the decimal method is meant to be a shortcut, is the idea. Just like we did in 6.1 and 6.2, you might have to make a couple conversions. So let's say I take 6,500,000 millimeters, and I want to convert it to kilometers. Well, on here, on this diagram, I don't have a direct conversion from millimeters to kilometers, but I do know that there are 1,000 millimeters in a gram, or in a meter, excuse me, and there are 1,000 meters in a kilometer. So I could do two conversions to go from millimeters to kilometers. So to do that, if I'm using my unit conversion or my unit rate, I would take 6,500,000 millimeters. I'd multiply that by 1 meter for every 1,000 millimeters. So again, essentially just dividing by 1,000. Whether you want to pull out your calculator or move your decimal, you end up with 6,500 meters. And then do it one more time. There are, for every kilometer, 1,000 meters. Same thing, dividing with a calculator or moving the decimal over, I end up with 6.5 kilometers, like so. So a metric system should be pretty easy. You're just moving the decimal either to the left or to the right based on this diagram. This is also included in the PDF under supplemental resources. That's all for today. If you guys have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.